Okay, so in this lesson, still dealing with exponential functions, we're going to look at part two. In part two, we're going to talk about domain and range, and we're also going to discuss whether the function is increasing or decreasing. And then we're going to look at a couple of problems where we're dealing with reflections, just to remind you what that looks like. Okay, but first of all, let's talk about these functions and determine the domain and range, and also determine whether the function is increasing or decreasing. Okay, so remember, when you talk about domain, you're going from left to right along the x-axis. And so domain, remember, is a set of x-coordinates. So remember this graph, the arrow keeps on going down. Now keep in mind that this graph gets closer and closer and closer to the horizontal asymptote. Now remember, this horizontal asymptote happens to be the x-axis. So the horizontal line, the horizontal asymptote is y equals 0. So these x-coordinates, as I go to the left, these x-coordinates are getting closer and closer and closer to 0. So remember on the t-table in the previous lesson what that looked like. So when x was -1, if I look at 2 to the x, if x is -1, I get 0.5. If x is -2, I get 0.25. So notice my y values are decreasing. When x is -3, I get 0.125. So they're getting smaller and smaller and smaller. They're getting smaller at a slower rate, but notice it's never going to cross the x-axis. Remember this graph for 2 to the x never crossed the x-axis. So it never touched or crossed the x-axis. These y values were never negative for this function. So it's getting closer and closer and closer to 0, the x-axis, which is y equal 0. Okay, now here's the idea with domain. Remember when we talked about previous functions, we included the brackets with domain and range if we needed to. So the infinity, negative infinity was always parentheses. Okay, same thing here. Now, as I go from left to right, notice that when I keep going to the left, if x is, let's say, -100, I'm gonna get a y value. It'll be very small, it'll be close to 0, but I'll get a y value. When x is -1,000,000, I'm gonna get a y value. It's gonna even be smaller, but it will not be 0. It'll be very close to 0, and so on. So I'm going from negative infinity for the domain. I'm going from negative infinity all the way. Remember, this arrow keeps on going. And so when x is 100, I'm going to get a y value. It's going to be very big. When I get 1,000,000, I'm going to get another y value. It's going to be very big. So I'm going from negative infinity to infinity. Okay, so domain, in fact, if you look at all of these, the domain of all exponential functions, is the same. The domain for all the exponential functions is all real numbers, negative infinity to infinity. The domain here is also negative infinity to infinity. Just like when you graph the quadratic function, remember the parabolas? The domain were always the same, all real numbers, negative infinity to infinity. All right, so domain, negative infinity to infinity. All right, now the range, just like when you graphed the quadratic function, the range was not negative infinity to infinity. It depended on where the vertex was and whether the graph went up or down. The same thing for exponential. It depends on the horizontal asymptote. Your range depends on the horizontal asymptote and whether the graph is above or below that horizontal asymptote. And all these three right here, the graph's going to be above. In one of the examples we're going to do in a little while, the graph's going to be below because that's a reflection. So we can talk about reflections. All right, now here's the situation. I go along for the range. Now you got to be careful with what I'm about to say. For the range, you go along the y-axis. I start touching the horizontal asymptote, in this case, at y equals 0. All right, now remember, we're talking about the graph here. So the graph is what you're looking at. So the graph is getting closer and closer and closer to this horizontal asymptote, but doesn't touch it. So it's getting close to 0 without being 0. My y-coordinate is getting closer and closer to 0 without being 0. It's like 0.999, I'm sorry, 0.000999 and so on. Okay? So it's getting closer and closer to 0. So when you write the range, you're going to start at your horizontal asymptote. But it's going to be in parentheses because my y value is never going to be 0. So you're going to say 0, comma, and then you keep on going up to infinity. All right, so the range there is for this, there's when you start at the horizontal asymptote or end of the horizontal asymptote, that number is always going to be parentheses because the graph does not touch this horizontal asymptote. So my y value is never going to be 0. It gets closer and closer and close to it without being 0. Okay? Same thing here. The range. I start touching the graph. I start touching the graph I drew at this horizontal asymptote. Now remember, this horizontal asymptote crosses the y-axis at -2. So my equation is y equals -2. So I say from -2. So you see this graph as I go to the left. This graph is getting closer and closer and closer to this horizontal asymptote, which has y value -2 without touching it. So you say -2, comma, infinity. -2 to infinity. And number 3, here you got to know how to write this equation. This horizontal asymptote crosses the y-axis at 3, so that means my equation is y equals 3. It's a horizontal line. All right, so again, as I go to the right this time, you see my graph's decreasing, so as I go to the right, my y values are getting closer and closer to 3 without becoming 3. So my range will be from, remember I start touching at the horizontal asymptote, so it's parentheses 3 all the way, and it keeps on going up, so all the way to infinity. Okay? All right, now in terms of decreasing and increasing, you remember read a graph from left to right. So as I go from left to right, my function, meaning my y values, are increasing. So f of x is increasing. Here, my function is also increasing. So f of x is increasing. And here, my function is decreasing. My y values are getting smaller and smaller and smaller. So f of x is decreasing. All right, let's talk about what the base is, just to remind you. Okay, so if my function is increasing, if the function is increasing, remember what that means. That means that b is bigger than 1. That's what that means. My base is bigger than 1. So something like 1.6 to the x power, 2.8 to the x power, and so on. All right, so here my function is increasing, so my base is bigger than 1. All right, now here my base is decreasing, so that means that, remember, get that proper fraction for your base. So, and your base has to be between 0 and 1 for that one. So since my function is decreasing, it has to be that. So this, it could be this. It could be something like, let's say, f of x equal 1/5 to the x, and then let's use the horizontal asymptote plus 3. Okay, so that's what this could be. So notice that my base is between 0 and 1, so it will decrease. That's what makes it decrease. Your base talks about the decreasing or increasing. Okay, so we saw that in a previous lesson. So when we graph, just remember that when we graph this, so we talked about this, that number 1, the base was 2, number 2, the base was 2, so notice the graph was increasing in both cases. Remember that? All right, over here in the previous lesson, my base is a half, so that's between 0 and 1. So we talked about this. And so notice that my graph is decreasing. My y values are getting smaller and smaller and smaller. Okay? And then here, my base is a third, so that's between 0 and 1, so my graph is decreasing. Okay? All right, now, let's look at this. Okay. So, just kind of review a couple of things. The exponential function f with base b. So in other words, you're looking at this. F of x equal b to the x. That's what you're looking at. So notice there's no number in the outside, so it's just b to the x. Okay? So the exponential function f with base b is defined by f of x equal b to the x. That's what this is. With b greater than 0, and remember b cannot equal 1. Using interval notation, the domain is, so let's talk about if there's no number, if there's no number out here, and that's meant to be plus 0, okay? So that's going to help us with the range. So the domain of an exponential function, remember, is always going to be negative infinity to infinity. Okay, so all exponential functions, domain's the same, negative infinity. Now the range depends on the horizontal asymptote and whether the graph is above or below. We haven't talked about reflections yet, so these graphs can be above the horizontal asymptote. Now remember, the horizontal asymptote is y equals 0. So in your mind, this is what you have. This is what you have in your mind. So you have this, the horizontal asymptote, and you're told that b is greater than 0, so it's increasing. Okay, and so the range will be from 0 to infinity. So 0 to infinity. Okay. All right. The graph of an exponential function with base b approaches but does not touch the x-axis. All right. So let's look at this. So you remember this graph, as you go to the left, is approaching the this x-axis right here. So the graph of an exponential function with base b approaches but does not touch the x-axis. The x-axis whose equation is, now remember the x-axis has the equation y equal 0. Because remember, it crosses the y-axis at 0 right here. And it is called a horizontal asymptote. Okay, horizontal asymptote. All right. Okay, now determine whether each of the following is increasing or decreasing without graphing. Okay, so we don't have any reflections, so we shouldn't have any issue with this one. No reflections. So remember, to determine whether it's increasing or decreasing, you look at the base. The base is 8. So since b equals 8, that's 8, which is greater than 1, the graph's going to increase. Here, the base is 2/3. So since b equals 2/3, which is between 0 and 1, the graph will decrease. So increasing and decreasing, it has nothing to do with the horizontal asymptotes. Remember, these are your horizontal asymptotes right here. Y equals -5 and y equals 2. It has nothing to do with that. It has to do with the base. Okay. Now, if there was a reflection out here, then that would change our orientation. All right, but we haven't talked about reflections yet. Over here, determining the without graphing, determine the domain and range. All right. Well, domain. Remember what kind of function this is? These are exponential functions. You have the exponent containing the variable. And domain for this, so these are exponential functions. Remember, we talked about the fact that the domain is going to be in negative infinity to infinity. The range, though, depends on your horizontal asymptote and whether the graph is above or below. Since we're not talking about anything dealing with reflections, these graphs are going to be above the x-axis. So if you look at number 3 right here, and let's say this right here is your horizontal asymptote, y equal -6. Okay, remember that y equal -6 is your horizontal asymptote. The graph is above it. The base is 2, so it's going to be increasing. So let's say it does something like this. Okay, so what's the range? Well, you go for the range, you go along the y-axis from bottom up. So I start touching the graph when I'm at this y-intercept. This horizontal asymptote, which is y equals 6, and so it'll be from 6 to infinity. Parentheses. Remember, it's parentheses because my y-coordinates here will never get to 6. It'll get closer and closer to -6. This is -6, but never touch -6. So it's y equal -6 to infinity. Okay, y equal -6 to infinity. Over here, g of x, number 4. If you look at the graph, so this time y equals 7 is your horizontal asymptote right here. So that's y equals 7. And notice that, again, your graph is going to be above. The 1/3 indicates that your graph is decreasing. So it looks something like this. All right. Now, remember, you're talking about the range, though. So it didn't matter whether it was decreasing or increasing, but it is decreasing because of the 1/3. So your range will be from 7 to infinity without including 7, because remember, your y values are getting closer and closer and closer to 7 without actually touching 7, becoming 7, or equaling 7. So So you get parentheses 7 to infinity. Okay? All right, let's talk about reflection. So first of all, let's look at this this graph. Let's look at let's graph y equal 3 to the x. Okay, y equals 3 to the x. So I'm going to use a t-table, and now remember there's no number out here, so recall that y equals 3 to the x is the same as y equals 3 to the x plus 0. So that means that my horizontal asymptote is y equals 0, or the x-axis. So y equals 0 and the x-axis are the same thing. So when I graph this, I'm going to draw my horizontal asymptote on the x-axis, kind of like this, just like this, and then let's plot some points. So I'm going to use the t-table to do this. So if x is 0, I get y equals 3 to the 0 power, which is 1. So I plot the point 0, 1. And remember, you are since the base is bigger than 1, it is going to increase. So my graph is going to do something like this. If x is 1, I get y equals 3 to the first, which is 3. So 1, 3. If x is 2, I get y equals 3 squared, which is 9. So I get 2, 9. Something like this. And so this portion is going to go like this. And then this portion, just do the best you can, just draw it to where it gets closer and closer to the x-axis. And so there's your graph. Okay? All right, so you need at least 3 points on this graph. So do something like this and then draw this part here. Okay, now we'll go ahead and put this on a transparency. So let's see. So we get this point, this point, this point, and here's my horizontal asymptote. That's right here. Okay. Here's my graph. Something like this. Okay, and go like that. All right, now remember, does your graph just never cross the horizontal asymptote for the exponential function? Okay, now. Okay, so this was, remember, y equals 3 to the x. Oops. All right, y equals 3 to the x. Let's graph 3 to the x. Okay, let's graph this. Y equals negative 3 to the x. Let's see what happens. So you see that negative in front, just like when we did the quadratic functions, that negative was a reflection about the x-axis. Same thing here. So this is a reflection about the x-axis. Okay, so in other words, when I do this, when I graph y equal 3 to the x, right here, and I look at the reflection at negative 3 to the x, I will get this instead. It'll be a reflection about the x-axis. So it'll be this. Okay? So the graph's going to do this. So instead of increasing, my graph will be decreasing. Okay? So instead of increasing, my graph's going to be decreasing. I still have the same, in this case, I still have the same horizontal asymptote. All right, so let's talk about this in terms of a t-table. So remember, this is the same. So remember, recall. Let's do this again. Recall y equals negative 3 to the x. Oops. Y equals negative 3 to the x, and then plus 0. So this is, since there's no number there, so it's to be 0. So y equals 0. Y equals 0 is the horizontal asymptote. Okay. So when I graph this, I'm going to get y equals 0. Just like this. Okay, now let's use the t-table just to help us. So if x is 0, I get y equals negative 3 to the 0. So remember, 3 to the 0 is 1, so this becomes negative 1. All right, so I get the point here, negative 1. If x is, let's say, 1, I get y equals negative 3 to the 1. 3 to the 1 is 3, so this becomes negative 3. So 1, negative 3, right here. If x is, let's say, 2, I get y equals negative 3 squared, so that's negative 9. Now be careful, just like with this, the only thing being squared is a 3, so this becomes negative 9, not positive 9. I'm not squaring a negative 3, I'm only squaring a 3. That's what this says. I forgot to put the 2 here. Okay, so 9. So I'm only squaring a 3. I'm not squaring a negative 3. All right. Okay, I'm sorry, negative 9. So I forgot to put negative 9 here. Okay, so I'm only squaring a 3, not negative 3, so it becomes negative 9. All right, so negative 9 right here. So when I graph this, I get 2, negative 9 right here. And so notice this part's decreasing rapidly. And this part goes towards the horizontal asymptote, just like you've been doing. And so there's a graph. There's your 3 points. You drew your graph. Okay? Now, let's talk about why this is decreasing. I want you to remember something. Okay, I'm going to cover this part up right here. So, remember, if the base is bigger than 1, your graph's going to increase. Okay? So it's increasing. So I'm going to draw that here. So watch. It's increasing. Here's your horizontal asymptote. Your graph is increasing. Okay? But there is a reflection. There's a reflection. So instead of your graph doing this, it's reflected about the x-axis, and it's going to decrease now. Okay, so this is increasing. It reflects, and so it's decreasing. Okay? All right, so let's think about what we did here. So going back over here, remember here's y equal 3 to the x, right here. So y equals 3 to the x. So when I reflected about the x-axis, I get this. Okay? So I get that. All right. So a negative out there indicates a reflection. Okay? All right, let's do one more with this. So let's suppose you want to graph f of x equal negative 4 to the x plus 3. 4 to the x plus 3. All right, now the base is going to be pretty big. So let's see what happens. Okay, now before we get started, let's think about this. What is a horizontal asymptote? A horizontal asymptote is y equal this number. Oh, and I forgot to do this, so before we go on, what is the range? Well, the domain, you remember, the domain for an exponential function is all real numbers. Okay, so negative infinity to infinity. But what's the range? Okay, so be a little bit careful now. So remember, in the past, your range, when we talk about the range, the graphs were above the horizontal asymptote. So you basically said, I start touching the graph when I'm at the horizontal asymptote. Okay, but remember, it actually doesn't touch the horizontal asymptote, but we use the horizontal asymptote from the range. So this would be from 0 to infinity. Okay, so the range here will be from 0 to infinity. But since it's reflecting here, this is y equals negative 3 to the x. Since reflecting, remember the arrow's pointing down, so I go along my y-axis, so I'm going from negative infinity all the way to the horizontal asymptote, which is y equals 0. So here, the range is going to be negative infinity to 0 with parentheses. Okay? So here, when you go along the y-axis, you start at the horizontal asymptote, and you go to infinity. Here, you're actually starting at negative infinity, and you stop at the horizontal asymptote. With parentheses, though, because remember, it never touches that horizontal asymptote. All right. So the horizontal asymptote is y equals 3. Now, here's the question. does the graph without graphing, okay, without graphing, is f of x increasing or decreasing? Okay, so if f of x increasing, decreasing. Well, first of all, look at your base. A base is 4. Okay, base is 4. So if this wasn't there, my function would be increasing. Okay, my function's increasing. But since this right here indicates a reflection, my function is going to be decreasing. Okay, so here's what to think about. Since the base equals 4, since base equals 4, I mean, be careful, I'm not going to say f of x because f of x is this whole thing. Since base equals 4, 4 to the x is increasing. But since there's a reflection, okay, so remember your horizontal asymptote is y equals 3. All right, since there's a reflection, it's going to be reflected about the x-axis. So instead of increasing, it's going to be decreasing. Okay, so it's reflected about so it's reflected about the x-axis. So it's decreasing. Since there's a reflection, f of x will decrease. Okay, so f of x is a decreasing function. All right. Okay, so what you need to do first is go ahead and graph the horizontal asymptote. So graph the horizontal asymptote. So the horizontal asymptote is y equals 3. So 1, 2, 3. So right here. So you draw your dotted line, just like this. All right, and you know your graph is going to be below. All right, so keep that in mind. Your graph is going to be below because 4 is increase greater than 1, so my function is increasing, but this makes it reflect. So it's not going to be decreasing. I'm sorry, reflect about the x-axis, and it will actually be decreasing. All right, so so let's graph some points here. Let's plot some points. So if x is 0, I get y equals negative 4 to the 0 plus 3. Okay, so that's 4 to 0 is 1, so that's negative 1 plus 3, which is 2. So I plot the point 0, 2. So 0, 2 is here. Okay, remember it's decreasing, so it'll decrease rapidly. If x is 1, I get y equals negative 4 to the first power plus 3. So that's negative 4 plus 3, which is negative 1. So I get 1, negative 1. So 1, negative 1, which is here. Okay. If x is 2, I get y equals negative 4 squared plus 3. So that's negative 16 plus 3, which is a negative 13. So 2, negative 13 is going to be, let's say, around, let's do this. Let's say around here. So that part's going to look like this. Okay? That part's going to look like this. Now remember, this part goes towards the horizontal asymptote without touching it. So do something like this, and you're done. That's all you do. Okay? Now, what's the range? Now, the domain, y'all know, is going to be all real numbers since this is exponential function. So negative infinity to infinity. The range, remember, since I'm below my horizontal asymptote, the range the range will be from negative infinity to y equals 3. Remember, this is y equals 3. So negative infinity to 3 with parentheses. Okay? All right. Now, remember when graphing these in terms of transformations, you always do the vertical translation last. So if that wasn't there, so you would say, remember this is going to be a reflection about the x-axis. All right, so 4 to the x. Says don't look at this yet. So my horizontal slope would be y equals 0. Reflect, so that's a reflection about the x-axis, and then you move it up 3 units. So that's what you see here. Okay, so moving it up 3 units. So all this was moved up. All right. Okay, so that should be the end of this. So that's how you graph this. It's not that bad. Just go ahead and review it again if you need to.